So welcome back, everybody. This is Galen from the library, and welcome back to Dave
Thank
for
you,
our
Galen.
fourth and most mind-numbing
It's going to be brutal,
talk.
guys.
This is advanced gardening concepts. And I just, from your previous talks, just started thinking about the upside down, the underground, like what's going on under
That's
there.
what
and
matters
It's
the most.
fascinating. I've been neglecting to say, because this program and others we have coming up are under our garden grant. And I'm supposed to be acknowledging our funders. So I'm going to announce that these programs, and Sarah in the series, she had one last Saturday, and on this Saturday, she's doing foraging in winter, and that will be here from 1 to 3 here. So that's medicinal herb series for anyone who doesn't know who Sarah is, and you can grab a flyer on your way out. So the programs are brought to you with federal funds provided by the Institute of Museum and Library Services and administered by the Massachusetts Board of Library Commissioners. And they gave us a nice grant that we're going to be building mud kitchens and cold frames and doing work with teenagers, and eventually hoping to segue that into a whole forest, edible forest that goes around the back of the library, nice places to sit down. And I think we should paint murals and really go to town, but we'll see what happens. So with no further ado, Korean natural farming.
No,
Organic.
Beyond
organic.
organic. It's a 3 subject.
3 subjects.
And that's, I'm going to begin my talk with preface it at when I initially thought about this 4th class, because this is stuff that I'm really involved with in my own teaching and learning right now over the last many years. I wrote it down, and then as I started to create the outline, I realized that this is really kind of intense. It should probably be broken up into 3 subjects: regenerative ag, Korean natural farming, and biodynamic farming. All 3 types of farming that I incorporate on my farm. So that being said, I'm going to rush through the slides kind of quick. I'm going to encourage you to contact me with questions later, but I also want you to go down the rabbit hole of all 3 of them if you choose. And I'll give you some resources to do that. But
and just along those lines, that
Yep.
we want you to give us a list of books we can purchase for people to check out. If there are any that relate to this.
yeah,
particular
we'll do that
subject.
later, because
Yeah.
these books aren't, I mean, aside from regenerative agriculture, but there's not a lot of Korean. This is all very new. It's only been in English speaking country since 2011, no, 2009. So it's relatively new to English speaking, and you're going to see a picture of my teacher. But biodynamic farming is well entrenched, it's been around for a very, very long time, and I've been using that on my farm too. So that is my little preface, and I apologize for the speed at which I'm going to have to get through these slides, but we'll talk about general things in the beginning and see how it goes. Biodynamic farming might get a little shut off the end there. You might have to enjoy Rudolf Steiner on another day. Okay, so there we are, beyond organic. We've already spoken a lot about organic farming in essence in my last 3 classes. Those of you who know my history, I some new faces I haven't seen yet. My name's Dave DeWitt. I have been farming here in Truro for 35 years organically. It's one of the 2nd certified organic farm on Cape Cod. I work for the company that certified the organic farms. I've helped create a lot of the agricultural community that's now here today, that we're really fostering a beautiful agricultural community here. I have I studied soil and plant science, and have been recently transitioned my farm over to Korean natural farming methods after this will be year 4 using KNF. Korean natural farming stands for KNF. You're going to see a lot of acronyms. So that's me. I'm at the farmers markets. Pretty easy person to find in this town. All right, you're going to dim the lights for ooh. All right, so here we go. And I once again apologize for this one. This one's a work in progress. I've never given this lecture before, so we're going to tweak it. And you guys are my beta guinea pigs. Okay. Does that look familiar to anyone, that slide right there, that picture? That was what we've been talking about the whole time, and it hasn't changed. Every single one of my topics has revolved around the soil. The soil is a living organism. It breathes, it eats, it evacuates, it has waste, it's a cycle, it's a system, carbon nitrogen system, oxygen system, carbon dioxide system, sequestration of carbon. Okay, it's a living organism. It's very, very, very biological, and that's a part we've been learning about in the last, predominantly in the last 15 to 20 years, but certainly in the last 5 to 10 years, we're really getting leaps and bounds, understanding the true nature of what the soil is. We can't live without it, guys. I'm going to give you a quick overlay of what happens in it. So, all right, another thing. Everything here might be geared towards agriculture and farms. Everything can be scaled down, okay? The concepts are the same, whether it's your garden, a rangeland you want to restore, a 10,000 acre wheat farm. It doesn't matter what it is. If you're a gigantic dairy farm, it doesn't matter. It's all the same principles are here, okay? So a quick history of where our soils and how we got here now. Of course, we were native soils. Everything was grown right in the earth. Everything worked in a good cycle, nitrogen cycle, the carbon cycle, everything was beautiful. Humans got involved. We began to kill off species. Then we really ramped off the killing of species with modern agriculture, starting with like the current chemical fertilizer uses in the 20s, really ramped up in what's called the Green Revolution in the 40s and 50s, particularly after World War II. A lot of chemicals left over. At that point, our understanding of agriculture and soils was more of a chemical nature. The minerals in the soil, the phosphorus and potassium, boron, magnesium, all these things, right? We didn't have the technology, the microscopes. They didn't know. I mean, they could see the mycelium, they could see the worms, but that was really about it. They couldn't, and the little bugs, they couldn't see the microorganisms that are there. And currently, I don't remember the exact number, but it's an unfathomable amount of if we pick up a teaspoon of soil anywhere in the world, we only know about like something like 0.001% of the organisms that are in that 1 tablespoon of soil. We know nothing about soils. We are just starting, okay? So back in the day, back in the 40s, they had no clue. They farmed the way they farmed organically. Okay, that was the way it was. Small farms, family farms, farmers sharing their seeds, genetics, techniques. Okay, they were manuring, they were cover cropping, they were cycling nutrients. Things were going pretty groovy until someone decided, hey, these chemicals are the same chemicals that plants need to grow. We've learned that about this chemistry, nutrient-based, mineral-based idea. So they created these salt fertilizers. In the process of that, yields went up. Farmers loved it. They all jumped on board. Hey, I can grow more bushels, I'll make more money. I can buy a bigger house, maybe get a couple horses, whatever. Send my kids off to school, put them in nice clothing. So the boom of agriculture began with this chemical fertilizer. As time went on, plants got weaker. So they, in tune exactly right around World War II and stuff, really a lot of chemical pesticides became involved. So as the plants got weaker with the chemical fertilizers, which now bypass the traditional biological system that had been passed on since the natives, those systems are now gone. The biological system was ignored. They didn't know what it was. They didn't have the word biology for it, but now we knew that the chemicals were doing it. But what happened is the plants got weaker. Pests then can attack the weak plants. Okay, so that's the snare that got us into where we are today. We started to lose organic matter because we didn't have to put all this manure back on the field anymore. We can now, or we have a part of the field fallow or in a cover crop. Now we could plant everything, give it chemical fertilizer, get big yields, and be more productive in one respect. Okay, so that's kind of where we got with our agriculture. That's still where we are today. We're even 1,000 times worse than we were in the 40s. Erosion happened, soil erosion, soil organic matter didn't go back to the farms, the Dust Bowl, et cetera, et cetera. Okay. I'm not going to propound too much on conventional agriculture, but it has not worked. Our soil test analysis are all mineral-based chemical stuff. Now we're beginning to get into the biology. We're having biology tests. We can learn about fungi and their relationships, like we talked about in our first class of soils. That's where I started with soils. So that whole soil food web that we talked about it's really the key to this whole thing. Okay, so the soil food web is where you want to be. Are you?
Oh, yeah,
Can you?
it's very, try it.
So a soil food web is the key to all of these three things I'm going to talk about today.
Is it working?
Okay, and that's where it starts. Nice, friable, good, crumbly soil, full of aggregates, lots of diversity, water holding capacity, a recycling of minerals. The fungi and bacteria are getting the minerals from the nutrients from the minerals, delivering it to the plant. The plant, they're communicating with each other. I'm not sure if some of you weren't in my first class, but we talked a lot about how plants and microorganisms communicate and create the environment that they have. Okay, so that's the basics. Okay, regenerative agriculture. Does this also look familiar? Because I've been beating this down to everyone since the beginning too. Healthy soil equals healthy food equals healthy people. Okay, back in the day, our food was more nutrient dense, had more nutrients in it. Now we have a real problem with bionutrients in our food. The carrot today is not the carrot that it used to be. The USDA's label for what a carrot is from the 50s, totally outdated. And the way we grow food is different. So conventionally speaking, our food source is very unhealthy right now. What we're getting at the stores is absolutely atrocious as far as nutrient biodensity, okay, nutrient density. Okay, so healthy soils, healthy food, healthy people, okay? Regenerative agriculture is a system approach to farming that builds a soil health by supporting biodiversity above and below the ground to return carbon and nutrients back to the soil. That's what we talked about. There's your soil food web, okay? That's what we've been talking about. Once again, building soil. That's the key to this whole thing. And biodiversity is another key word in there that we really need to get into it. So we have these sick and dead soils in our country, in the world, all over, that we've trampled on with machinery and chemicals and asphalt and all sorts of things. We've cut down the trees. We've done a lot of things. We've diverted the streams because the beavers can't hang out anymore. So that the waters, they don't dam the rivers like they used to. We've changed things on a real global scale. Insects, a whole bunch of biodiversity. So regenerative agriculture really is about revitalizing and regenerating these soils back to their full potential, okay? And we're gonna do that by fostering the soil food web, okay? Regenerative agriculture is a system of farming principles that rehabilitates the entire ecosystem and enhances natural resources rather than depleting them. Coming up with some of these definitions and things and borrowing and pasting from other people, this one's really key for me, okay? This is where we are now. What can we do now to bring our garden soil and farm soils back into health, okay? So we need to really start to look at how we can do that, okay? The number one, bad slide. The number one priority in regenerative organic agriculture is soil health. That's why it's in the little bold letter, okay? All right. Crop and rangelands can be regenerated, soil organic matter can be recovered and built, and soil life can thrive again through regenerative agriculture. Through the practice of regenerative agriculture principles and techniques, we can do this, guys. It's being studied, tested, data's there. It's changing the way a lot of the USDA people who are the old school are slowly getting replaced by the younger and the new biological model that we're now looking at, a holistic model as opposed to just the chemistry. We're not just testing pH and cation exchange capacity. All those things are important, but we've got to talk about biology, and that's what this is. That's how we're going to do it. All right, such as we can get all that done by diversifying crop rotations, planting cover crops, green manures, perennials, and rotating crop, retaining crop residents, leaving stuff on the ground. We never leave the ground soil bare, as we learned a few weeks ago. Using natural sources of fertilizers such as compost. Employing highly managed grazing and integrating crops and livestock. Now, this is the thing that everyone in the garden world might be like, oh, Dave, what are you talking about? We're having a garden class, and you're talking about livestock okay? So like I said, let's scale it down, okay? Livestock is actually a very integral part. Animal nutrient cycling, any animal, whether it be the elk, the deer, the beaver, the possum, the rat that's turning your compost, all these animals are moving and cycling through their nutrients. They're eating them and then they're pooping them out, and we're getting their manures, right? The rangelands were very productive when we first got there. Why? Because there were thousands and tens and millions of bison and animals. You look at some of the Lewis and Clark journals and documentation, which have been highly vetted and are very thorough. They would come up to a valley in somewhere in Missouri, wherever they were at the time, and they would see 1,000 species of animals just by where they looked out. They could see everyone living together. I mean, it was like that kind of like Garden of Utopia type thing, where all the animals are going down Sahara, in the African plains, and there's everyone living in consistent, with each other. So animals are a very integral part of regenerative agriculture. And I personally feel, as a Buddhist who doesn't like to kill animals, that animals are a very integral part into this system, okay? And the way we can do it at home, in our small homes and our small gardens, is with chickens, okay, or rabbits. Those are two very efficient feed to protein ratio, efficient in processing protein in to protein out for humans, okay? Very little impact on the earth, okay? They're not big stomping animals. Nothing wrong with cows, but we're not going to have that in our backyard in Truro, unless you're Drew Lock. Maybe you will, or the Moonies. But so when I'm saying employing highly managed grazing and integrated crops and livestock, really working with how we manage our livestock and our grazing is the key part. We've been doing it wrong. We've been abusing the earth and abusing the animals, as we all know. Factory animal production is a disgrace upon all of humanity, and all of us that eat animals like that. I fortunately only eat my friends' animals now, so I'm a little bit feeling a little better. Okay, so reduce tillage frequency and depth, very, very key to regenerative farming. I am practicing no-till now. I have a small portion of my farm I'm getting under control using light tillage. I no longer set my rototiller all the way down. I now go as high as I possibly can, and I do minimum tillage. What happens when we till? It breaks the soil structure down, ruins the tilth, the health of the soil. All that beautiful mycelium that's crawling through underneath the soil, underneath our feet, gets chopped up in little bits and gets ruined, okay? And those are the way that the plants are communicating with the world, okay? All right, eliminating synthetic chemicals. The reason I have that on there is because those kill microbes. Those kill fungi. There's lots of studies done where we talked a little bit about seed coating of fungicides, remember, during our seed class? That seed coating with a fungicide, you put that in the soil, you kill all these microorganisms for like many square meters past that little seed. You put 10,000 or 100,000 or 200,000 seeds in a cornfield in Illinois, where I grew up, and you've poisoned the soil with these chemicals. So the synthetic chemicals kill the soil food web. Regenerative agriculture, we have to regenerate it and bring it back and foster the soil food web. So at home, chemical fertilizers. What's a good one? Miracle Grow, good one. People love Miracle Grow. Awful for the soil, awful. When it goes out of your house plant into the water system, down your however it goes away, awful. Okay, so think about what you're doing to the earth that's going to foster the soil microbes. What I learned this weekend through Dan Kittredge, a wonderful farmer, at my conference I was at, was what would nature do? He kept saying it. Well, of course, he had 6 hours to talk, and I only had one, but he kept saying it over and over. Well, what would nature do? Someone had a question. Well, what would nature do? Okay, so that is exactly what we've got to think about. In nature, what would the forest do? How does it recycle nutrients? We want to mimic nature, okay? All right, I'm going to try to go faster. Carbon sequestration and how it works, okay? Carbon sequestration is the beauty of regenerative agriculture. Regenerative agricultural farms and gardens in this country can sequester a lot of carbon, okay? Poorly managed farms adds carbon dioxide to our atmosphere, helping create the problem that we have with global warming. Wrong type of animal raising, livestock production, the way we do it, is very negative on our carbon footprint. Yeah, they're alive, but they're polluting, okay? So we have to get it figured out. Photosynthesis is how it starts. We talked all about this, guys, in that first class, okay? It takes carbon dioxide and turns it into sugars. They go into the soil. Okay, that begins the whole process of the soil food web. Those carbohydrates feed the bacteria, okay? That's what's happening. Bacteria say, I need some of this. The plant brings in some things. The plant communicates telling, I need this, and you get it for me. All right, nutrient exchange. So we got photosynthesis, nutrient exchange. The plant-derived carbon enters the soil in the form of litter or root exudates. Those are those carbohydrates that the plant puts out for the microbes. Soil microorganisms, fungi and bacteria, but there's also yeast and protozoas and nematodes and diatoms and all sorts of things going on, live in association with plant roots and decompose these organic compounds. During the decomposition, nutrients, nitrogen, phosphorus, etc., are released to support plant growth. That's the nutrients that the plants need, not the fertilizer we give it. It comes from the earth already. Okay, so if we bypass it, think we're going to intravenously feed it with some 10-10-10 fertilizer that my parents and grandparents might have used. That's the problem. The nutrients are already in the soil. We have to get the microorganisms in the soil food web running in good function, and then they're going to go get the nutrients. The plant's going to ask for it. The microorganisms are going to get it, and we don't have to do any work. Okay, all we got to do is keep the soil covered, cover cropping, manure management, composting, and then a few cool tricks I learned in green energy farming. Okay, capturing carbon, microbes. Okay, Nematocrass is a dead microbe, the biomass of dead organisms. Okay, can be stored in sorry about that, organomineral associations or microaggregates. Microaggregates are these little soil clumps that happen in the soil that lets gases exchange and nutrients and water flow through. And you've seen good soil where it's kind of crumbly, right? And you've seen sandy soil where it just falls out of your hands, and you've seen clay soils where it's really tight, right? So all these types of carbon can help build the aggregates on our soil. This physically protects stable carbon. The way it pulls that carbon in, it can make it, it stabilizes the carbon and keeps it in there in its original form. Okay, so carbon that is, we can hold carbon in from the plants and from the atmosphere. Restoring balance. Increasing the numbers of microorganisms in the soil helps bring carbon levels back into balance, which leads to a healthier soil, healthier food, and healthier planet. Okay, so regenerative farms all around the world, plenty of data, is sequestering more carbon than things like putting solar panels on our roofs, putting up windmills. Okay, this is offsetting carbon. Those appropriate technologies. That's part of the process. This is the most natural biological process. The dirty secret is those photovoltaic panels on all of our roofs, and I'm a huge proponent of solar. They're not recyclable. Okay, they're very toxic, and they have a short life. So get the longest ones you can get that have the best longest life. But in essence, when these things start to come out of their life expectancy, we don't know what we're going to do with them, and we don't know how we're going to clean it. So here's this clean energy that's got this big dirty secret. Okay, so this way of sequestering carbon is beautiful. Okay, this is natural way of doing it. Farms are getting big companies that pollute the earth have to get solar or carbon credits to get their tax things down. They're using farms to sequester carbon because we're like my farm in Truro is sequestering far more carbon than my farm is producing, and even my neighbor's house, Sebastian's. Okay, so there's like we're just. And then even way more because we have a mushroom operation, and that really sequesters carbon. Okay, so just my little farm is doing a lot more, and it's really helping the earth. Okay, so regenerative agriculture and sequestration of carbon is huge. Nitrogen, carbon does not cycle alone. There's something called the carbon nitrogen cycle on our planet, and you can Google it if you want to get into it. But that's how this whole system works. The type of nitrogen used in an agricultural system is linked to the carbon storage capacity of that system. Chemical nitrogen does nothing to sequester carbon. Okay, the only way you're going to get nitrogen to help sequester and work in the carbon nitrogen cycle is by composting, mulching, fostering the soil food web. Okay, when compost replaces synthetic nitrogen, plants grow more roots. Proven. Fungi, super important, guys. Fungi to bacterial ratios are ecologically important for carbon storage and overall farm system sustainability. That is the same process of the fungal bacteria common ratio in the soil. Those organisms working together, the bacteria going through the mycelium to talk and communicate. The bacteria goes inside the plant cell, okay, and communicates and helps bring more fungus up into the plant and helps defend the plants naturally from pests. Okay, the fungal to bacterial ratio on the earth is very important. We need to foster it more and more and more. Okay, Most of the crops we grow are fungal dominant loving plants. All the brassicas that we know are bacterial dominant plants. So we have a technique to get one higher or another. But generally speaking, we want to get a real fungal dominant fields and gardens and things like that. Okay. Increases in plant abundance, plant diversity, and organic fertility sources increase fungal biomass and fungi to bacteria ratios. The more plants we grow, the diversity of plants we grow. When Lewis and Clark were there were like 1,000 species of animals, and there were like hundreds and hundreds of species of plants in the same area. Okay, took a little square area. There'd be many, many, many types of plants, all different types of root depths. Some going deep to mine minerals up. Some putting out this kind of exudates, some putting out that type of exudates, everyone communicating through the mycelium and the bacteria. It was a very cool system. And then all of a sudden we decided, well, it's better for us to just plant wheat or corn or animals or whatever on all of the land and get rid of it. So, but when we increase the diversity of the plant abundance, everything starts, the engines start to roar, okay? And once it gets going, this is my 4th season with KNF. Once it gets going, it's incredible how quickly it happens. Diversifying cropping, I guess I was just talking about that. Whoop. Increasing biodiversity above ground, growing diverse crop rotations, cover cropping, strip cropping. We never really talked about intercropping. We did. That's where I grow a corn here and then some cover crop underneath, clover, vetch, something to build the soil underneath. They can live in harmony. Never want empty soil. So if you don't have plants growing there, then let's get some mulch down, or let's get some compost down, or some unbleached paper or something. Let's keep it covered. Okay. Not with plastic either, because I did that for a long time. Plastic mulches. Multi-story cropping, complex theory, but it's the same basic thing where you're got a walnut tree up here and then a crop down here and then another crop down here. So we're getting multi-levels in the same area, kind of leans on the permaculture idea of things. Okay. And integrating crops and livestock leads to resistance. Okay. So if we take our crops, our pasture land, our grazing land, and our animals, and we work them all into this system here, right? We're moving manures around, we're breaking up pest cycles. Maybe we got some late blight on our tomato crop. Let's move it through. Let's move the chickens in. Let's move the cover crops in. Let's go fallow. Those types of things build resistance in the soil, okay? And then it can handle a tough time like drought, okay? Regenerative farms handle drought far better than any other conventional agriculture, well documented. Very well. I mean, there's, you guys can go down these regenerative agriculture hole, regenerative farming hole, that rabbit hole, and I hope you do, because I have to go fast. Cover crops are equally important for large and small scale systems. I put that in there because even though I'm talking about farms, remember, we can break up our little plot, and even if it's this size garden, we can have this much right here in cover crops, or this much in cover crops, doesn't matter. And then we rotate it through the years in a crop rotation. Rebuilding soil, getting those microorganisms in place, okay? Mulches and compost, same thing. Let's keep the ground covered. We don't want open, exposed soil, okay? When you drive by a place and see it's farm around here and the soil's open, they haven't learned the process yet, okay? Got to be in cover crop or mulched and compost, okay? Retaining residues as mulch, compost made from plant residues and ornamental increases soil biodiversity. Okay, I'm getting repetitive here, okay? It improves soil structure. That's really critical though. We're going to get aggregates, we're going to get little glues, they're going to clump aggregate soil together. Okay, they're all going to glue together. Once that soil structure is going, respiration is better. Actually, carbon can get released from the air, the other forms of carbon that are not so bad. So nutrient cycling, okay? All this helps keep diseases and pests down, okay? Reduce tilling, really important. Switching from deep regular tillage to a reduced tillage program, improves soil structure. I didn't want to get into the no-till thing because people do like their rototillers. I understand that breaking new ground. There is some, there's some reasons we want to do some tillage, particularly when we're starting new gardens. But really is reducing that as much as we possibly can, all the way to a no-till where we're just flipping our soil over with a fork in our garden, or creating permanent bed structures like on my farm, where we just loosen the soil, put in the new crop, okay? Tilled, exposed, and eroded soils allow formerly stable soils carbon to be released as greenhouse gas. This is key, guys. This is how bad agriculture, unthoughtful agriculture, is creating more of a problem, okay, than we know. The other thing is formally stable soil carbon. We don't really have that on Cape Cod. I know there's some people on Zoom. I don't know where you're zooming in from, but on Cape Cod, we have sand, basically. Our soil is profiled. It's called the series. It's called the Carver series. You can look it up on the USDA map. But we're basically looking at moraine, glacial moraine, coarse sand. Okay, and the process of that erodes very quickly. Okay, it moves very quickly through the system. So we're trying. We got to bring organic matter in there to really get the carbon up. We got lots of minerals down here, guys. All that coarse sand is a lot of minerals, get a lot of nutrients for the plants, but we need the biology to utilize it. Okay, so that's the goal on Cape Cod. Increase the soil food web. Tilling clearly affects soil life. It breaks up aggregates. Remember those clumps I was talking about? Destroys the fungal networks. Oh God, this better. Increases water transevaporation. It loses water too quickly, and then drought comes in, and we don't have enough water holding capacity. Okay, increases the breakdown of organic matter quickly. When we're adding air to the system like that, we have oxidation. And on Cape Cod, we don't need to add air because we have so much air with our what's called macro pore space created by our sand. If we had clay, it would be a different story. We'd be trying to get more air into it. But either way, the solution is compost, mulch, cover cropping, and the foster the soil food web. Okay. Of course, you know, wind can water can damage it. We don't have that too much on Cape Cod. Grazing management, real quick, obviously. It can provide great potential to sequester carbon if it's done properly. Okay, it's really got to be managed properly. And then if it is managed properly, it actually sequesters even more carbon than systems without animals in it. Okay, so I put this in there. Livestock is not the problem. It's the way we have chosen to raise livestock that creates the problem. If we can raise our animals regeneratively, we can get more pounds per acre, which is what the bottom line is for the farmers. We can sequester more carbon, and we can have healthier food. Grass-fed, grass-finished beef has 2/3 less calorie than conventional beef. Let that sink in a little bit, okay? Because all you have to do, you want to lose 2/3 of your calorie intake, start eating grass-fed beef and grass-finished beef as opposed to what we buy at the Stop and Shop, okay? Just like that. That's very impressive thing. 2/3 less calories, okay? That's important in that, why livestock are important in that regeneration, okay? So we need to get a handle on our livestock, and I'm not a livestock farmer aside my chickens, but there's many great farmers in this country and all around the world that are doing a great job. So I know the paradigm shift's going to happen, okay? System complexity, I don't even want to, this is just, you know, regenerative agriculture is a knowledge-intensive system-based approach grounded in ecological thinking. We're no longer thinking about the minerals and chemicals of our soil only. Okay, we're in a much more complex concept and idea of moving forward with how we're going to produce our food. Okay, and in the process of doing that, we're going to have more biodense food. Okay, very important. Longer, more complex rotations, including cover crops. Perennials are important if we can get perennial things in there, trees, et cetera, et cetera. Get the different root systems to do more thing, and that'll help regenerate. Okay, these are all important principles. Okay. So there we are again. I wanted to finish regenerative ag with that. Soil health for a livable future. We can do this, guys. Our paradigm is shifting. We're really at the cusp of it. I've been an organic farmer for 35 years. When I learned about Korean natural farming, which we're going to talk about next, and I had my soils background, I was like, duh, why wasn't I doing this before? Right. So now Korean natural farming, we're going to get into it right now. Okay. And it starts with natural farming, not Korean natural farming, but natural farming. Some of you may have read the One Straw Revolution, okay? Back in the 70s, wonderful Japanese, I can never pronounce his name. There in 1913 and 2008. It is related to organic farming. It's related to sustainable agriculture, agroforestry, eco-agriculture, and permaculture. All of those are types of farming right now, different types of farming. And I should have thrown on biodynamic farming in there too. Okay, that kind of goes under. Now that's too esoteric. Biodynamic farming is esoteric. Okay, so natural farming incorporates all these things that I've done for my life. Okay, Principles of natural farming, avoidance of manufactured inputs and equipment. We've already talked about that. Exploits the complexity of living organisms that shape each ecosystem. We've already talked about that. Okay, more soil food web. The cultivation and perfection of human beings. Ooh. Close observation of local conditions, demands no inputs and mimics nature. Okay, all of these things we've already talked about, right? So we're jumping into Korean natural farming, yet the principles and the basis of Korean natural farming and natural farming is what we've already talked about in our last 3 classes, particularly that first class on soil and mulch and compost. Okay, so mimics nature, so important. Okay, what would nature do? Well, what would nature do? Okay, really important. Oh, what happened there? There he is. This is Master Cho, the creator of Korean natural farming. Okay, this methodology of farming was created by him. I learned it. I'm 2 steps away from Master Cho, and someday I hope to get to Korea and work with him and his family doing amazing, amazing work. Okay, it's funny he's got a Chris Trump shirt on. Okay, he invented the Korean natural farming method. I'm not going to get into detail, but he went to Japan in 1965 to study plant enzymes. Okay, he came back that with his knowledge of traditional Korean fermentation products and fermentations, kimchi, those types of things that we already know about. He blended some information together, what he knew about plant enzymes and plant structure and plant growth. He had a farm in Korea first. He was a researcher, went to Japan, learned about natural farming techniques from this gentleman up here, Miyoso Yagamishi and Kenichi Shibata, and this other gentleman. So those were his 3 teachers in Japan. He came back with this, he got this concept in his head, thinking about the fermentation process that they use so much in Korea, and boom, Korean natural farming was born. This is Chris Trump. That's my teacher. And I am glad to announce that he will be coming to do one of his very popular and intensive 5-day classes in the first week of October on my farm. You can go to his website and sign up for that. It is 5 full days, including a 6th day where it's more relaxed. And what he's holding in his hand is a sample of mycelium. I don't know if you can see it, and maybe not, of course, not on Zoom, but everyone else here. And that's actually the sample. He sent all the students out in the woods to go get a look for mycelium. By the, everyone's dug through the trees and seen the little fibers, right? The little white strands. That's mycelium. Those are the fungal networks that are creating this whole soil food web, are part of it, right? So he said, go out, everyone go. And I remember reading something about Master Cho going to the oldest tree, and then went there. So I went, everyone else went this way, and I went down by the creek in this big tree, and I found this big clump of mycelium, and he's using that as his example. I was like, when the teacher read your essay because it was a good one, and you're like, kind of like, yay. That's how I felt at this moment, right? And what he's standing next to is what's called an IMO box. Okay, ChrisTrump.com. He's got an incredible, this is the foremost English-speaking authority on Korean natural farming, along with a man named Drake, okay? Drake, Master Cho went to Hawaii. Chris Trump is a huge macadamia farmer. His family's 3rd generation macadamia farm in Hawaii was in bad trouble, as all the macadamia farms were. Master Cho happened to come to his island for the very first time to an English-speaking country, taught his techniques. Chris Trump and Drake happened to be there. Drake's website is pureknf.com, I think, or .org. PureKNF is how you find him. Once close friends seem to be kind of divergent, but there's 2 main teachers. There was a 3rd, she's passed away. The 3 of them were together at that site when Master Cho came. They since, Chris Trump spends all around the world now. He took a portion of his family's macadamia orchard, 1 acre of 670 plus acres, I think it was, and started to apply KNF principles. All of a sudden, the disease, everything's looking good. The leaves are greener. Everything's doing much better. Then they did, I think, went to 5 acres, and that was incredible. Then they did 50 acres, and eventually now all 600 plus acres are KNF only. He's the first person in the world to scale up the KNF, Master Cho's principles. Okay, Master Cho is working on small farms in Korea because that's what they have. But how do we bring this to Iowa? How do we bring this to the plains in the open spaces of Australia? How do we work this in the big rice paddies in Vietnam? Okay, so he took Master Cho's beautiful work and model, okay, and we never veer from it. Pretty much all, we can try and do new experiments, always with side-by-side trials. So he took that thing and it just ran with it, okay, and decided he wanted to ramp it up because for his own farm, because his farm was 600 plus acres. Eventually, word got out in the macadamia world. The head of the International Macadamia Society decided to come pay Chris Trump's and then his family a visit and walk through the orchard and said, I've never seen a macadamia orchard as beautiful as this or growing like this anywhere in the entire world. And would you please join our board and become, and work with our organization? So he's the foremost authority on this Korean natural farming and agriculture today around the world. He goes all around the world and teaches. And fortunately for me, he's my friend and he's my teacher and he's coming to Truro. So if you really want to learn how to do it, there's a lot to this, not a lot. It's simple, but it's pretty intense, okay? Not intense, but there's a lot of inputs because we're no longer buying anything outside. We're now making everything, all of our inputs on the farm are now made from plants around the farm and with a 10-mile radius, okay? So that's my teacher. He's got much less hair now. I just spent the weekend with him. Gee, that's being weird today. Okay. All right, basic theories of Korean natural farming. Use of indigenous microorganisms. IMO. I apologize, there's a lot of acronyms here, and I'm going to be throwing them at you real quick. But the foundation of all that Master Cho did was indigenous microorganisms. Our soils are dead. Okay, the soil we're walking on over here by the library does not have any of the bacteria in the life that it used to have before humans got here. Okay, so the indigenous microorganisms are in one place in more virgin native soils. Okay, in the forest. Okay, that's where the bacteria and the fungi live. That's where all those trillions and billions and gazillions of microorganisms that we don't even know what they are yet exist, okay? So the process of utilizing indigenous microorganisms to re-inoculate our soils, okay? It's different than going and buy what we call bugs in the jug. Okay, you can go to a fertilizer store, you can go to Bayberry and buy some mycelium and add it to your compost or garden and add that. Those are born in a lab, they're not indigenous. Indigenous microorganisms are mostly affected. You would think water and temperature would be the main things that would affect microorganisms, but barometric pressure. That's why Master Cho said, you go 10 miles radius around your farm and preferably 500 feet in the air. We can't do that here, okay? That's where you're gonna collect your indigenous microorganisms that you're now gonna bring back to your weak, damaged soils, okay? Maximize the potential of the natural environment, minimize the use of synthetic fertilizers, practice no-till, eliminate emissions of livestock waste effluent, okay? Using these IMOs and some of these other inputs that we use in Korean farming, we could treat the bedding of a piggery. I can spray lactic acid bacillus that we create. I can spray it in my chicken coop. And that ammonia smell, if you've ever had chickens that you don't clean out your coop soon enough, goes away. It breaks down things. It does this. It helps clean the effluent that can then pollute the earth. Remember I was saying the way we produce livestock is deadly. If we incorporate regenerative agriculture practices and then on top of that, throw on Korean natural farming, we're going to even do the better job of that. Increase production with less inputs. This was really important for Master Cho. The reason he was doing this and the reason he went to Japan in the first place to study plant enzymes was to help the farmer save money on these chemicals, fertilizers and chemical pesticides and fungicides, this wheel that the world is on, particularly in Asia and India and places like that. They jumped right on this chemical fertilizer bandwagon and got their inputs up and their yields up. And now they're paying the price, okay? So instead of going out and buying stuff, his whole thing is buy the least amount possible. You're gonna make everything on your own property, okay? I've saved thousands of dollars, and I can get into that later if you want. Lower costs to the farmers, as much as 60% a year, if not more. More desirable crops, better, healthier crops, stronger, healthier, more nutritious plants, higher yields, better quality, farmer friendly. I don't know if you know what a re-entry interval is. If you have a pesticide, every pesticide is what's called an REI, re-entry interval. If you put it down on a crop, if it's a 24-hour re-entry interval, you cannot walk into that field for 24 hours. You can't have a dog go in that field. You can't have a child go into that field. Okay, it has to be posted. Okay, when the mosquito people are spraying all around here, and you guys are all paying for the mosquito people to come take care of your mosquito problem. Okay, do you ever see them post an REI there? Never. Do you? Most of them are using pyrethroid. It has an 18-hour reentry interval. Okay, you're not supposed to go in there and do it. I'm walking out of one of my favorite restaurants in Wellfleet, and here comes the mosquito sprayer guy. Children having coffee and things, and he's spraying the trees. Oh, it's organic, he keeps saying. 18 hours. That same product he was spraying, because I went and investigated it and found out. I called the company and said, look, because I have my pesticide applicator license, even though I'm organic, I still have to have it because I'm a conventional farmer. I know the rules and the laws. No protective gear, no goggles. This guy was breaking the rules up and down. I'm not going to name the company, but I've noticed every single one of them around here doing the exact same thing. Okay, saying it's organic because it comes from organic source. Pyrethrum is organic. Pyrethroid is not organic. Okay, very important to know that. All right, where was I? Farmer friendly, zero waste emissions. We don't have any waste. Everything that our whole process of the KNF inputs we use goes back into the earth or into the compost and is completely used. Okay, aside from some glass jars and things we use to make our ferments. The other nice thing is every single input, including the IMO, believe it or not, is used on our plants. It's also humans can eat it. Okay, a lot of us use OHN, Oriental Herbal Nutrient. A lot of us use lab, lactic acid bacteria. We're making our own probiotics with a list of like 1,000 more probiotics of the lactic acid. The lab that we make in our farms has thousands more bacteria than all the probiotics you guys are buying at the stores. Okay, you want to get probiotic and get your gut healthy, you take some lab and you make it yourself, and it's cost of a half a gallon of milk. Okay, so the implants are made from natural materials which are not only safe for the environment but actually invigorate and rehabilitate the ecology. They also invigorate you. Okay, every one of these inputs that I'm going to briefly talk about, these ferments, we can use in our own bodies. If you can't use it, if you can't eat it, it doesn't belong in the KNF system. So that's one key thing. Okay. Okay, KNF and IMO. IMO is the key here, guys. This is the most important part. Okay, IMO consists of bacteria, fungi, protozoa, and nematodes, diatoms, and there's a whole bunch of other ones. Okay, the stuff that's in the forest when you move the duff off and you move the leaves. All those things are there, okay? Those are indigenous microorganisms, okay? KNF makes use of IMOs to exploit the full potential of the ecosystem in which the crops are grown. We're gonna bring that ecosystem from the forest, the untouched, ruined land from humans, and we're gonna bring it into our soil and try to rehabilitate and save the planet and shift the paradigm, okay? Potential benefits include increased soil rates of soil organic matter decomposition, increase in nutrient availability, improve plant yield, or reduce pathogenic microorganisms, which are the funguses, the blights, and the things that you're getting in your disease and your plants. This will help reduce it naturally, okay? And increase plant defenses, make it stronger so the squash bug doesn't get you, and the aphids, and this and the that, okay? If we can use our ferments, our fermented plant juice extracts that are high, specific ones that are high in silicate, the silicate gets up into the plant. Silica is very important for cell wall development. The cell walls get thick and strong, and the bad botrytis or the powdery mildew or the bad pathogen that's on our plants can't get its hyphae through that thick wall because you helped encourage a more cyclical cycle of silica being introduced into the plant. Okay, so if we need to do that, I typically use the silica, what's called FPGA, fermented plant juice. Okay, I'm sorry for the acronyms. If I use a ferment FPJ in the spring, it's to get my silica going. But now in year 4, I don't need to do that as much because my system's running, okay? The wheels get set in motion with these IMOs that we bring in there. We're collecting in the forest and we're bringing back. And when I say collecting, I don't mean I'm digging up a bucket and bringing it to the farm. I'll show you in a minute how we're collecting it. We're being very, very minimal disturbance, just like as much as disturbance as taking a walk in the woods, pretty much, okay? All right. Indigenous microorganisms are the most important input in all of KNF. You will get the most fertile land possible with indigenous microorganisms. If you're going to take one part away from my talk about KNF, the foundation, 90% of the importance of Korean natural farming is indigenous microorganisms. There's different forms, IMO 1, IMO 1, IMO 2, IMO 3, IMO 4, IMO 5. And these are ways of expanding, starting with a small amount of microbes, getting it all the way up to tonnage, okay? IMO 4 and IMO 5 is hundreds of thousands of tons we can apply to our fields, big fields, okay? That's how it gets ramped up and scaled up. IMO fosters the best microorganisms for your area, with your barometric pressure, your temperature gradient, your water flow, all your soil structure for your environment. Not bugs in a jug that we're buying. We're not buying mycelium from a lab in California or Colorado because some pot growers thinks it's the best thing in the world. Okay, it's not relevant. Okay, it's really it doesn't have the right food source. When it gets in the soil, it's dead within 4 weeks. Okay, everyone thinks, oh, 4 weeks is great. 4 weeks of mycelium growth is great. No, it's kind of a waste of money, basically. Okay, this is my opinion. Well, not mine, but a few of ours. There are 5 stages to IMO, and each stage needs to be completed before starting the next. IMO, IMO 2, IMO 3, IMO 4, and IMO 5. I'm not going to get into detail about all those, and please go to Chris Trump's YouTube channel. And I know it's an unfortunate last name, but he's a brilliant man and a wonderful human being, an open heart, and very compassionate. Oh, I might say that Master Cho did say that all this has to be done with love. Okay, so that is where the basis of this comes from. The love of humans, and that's his philosophy as a Christian, and it comes through in his process here. Okay, that is an IMO box. This is, remember the box with Chris Trump sitting in front of it, holding my little thing in my stand. That was at the class I took, the 5-day class, where we go out and we actually take these IMO collections and we utilize, we make IMO 1, we make IMO 2, 3, 4, 5, we make all the ferments, we make everything you need to know about green natural farming. You can learn in 5 days. 5, albeit long days, but you'll be on my farm, we'll feed you, it's gonna be a nice thing. So you see all that fuzzy stuff, guys? That's sporulation of fungi, and it's white. So that's ideally what we're looking for, nice pure white. I've seen collections from Korea and places where they use a bamboo, okay? You don't use plastic, you never use plastic, anything. It has to be a breathable living surface. We use boxes in this country because everyone has a lot of wood. You don't go and buy a box. You find some wood that's around your property already or your farm and you make it. I use a basket, you know, a little basket, a wooden basket that whatever for Easter basket. I find them at the dump all the time. Not the plasticky ones, but the real wooden material. I put my substrate in there. Now, the substrate that this is growing on, okay, you fill the box 2/3 full with al dente white rice, okay? Yes, Cal Rose rice is the best, and there's a reason why, because there's a carbohydrate thing that balances with the microorganisms. It's a good substrate and a good food source for them. If you overcook it, you lose a lot of that. So al dente, like if you had a dinner party and that you fed some rice to someone and it's just a little crunchy and you sat there and go, it's a little undone, okay? And your guests went home and thought, they didn't cook the rice long enough, right? That's where you want to be. Like, it's edible, but it's just not like what we're used to for rice being. And brown rice does work if that's your next question, but white rice is cheap, affordable. These are one of the inputs we have to add to our Korean natural farming inputs is white rice, okay? So in this box is al dente rice, cooked 2/3. We go out to the woods, natural place, undisturbed by humans. We go to the largest tree, if you're Master Cho people, and you find a nice big tree, an old looking tree, move away the soil dust, the leaves, and you settle this wooden box that's now got a screen on the top because it has to breathe, like a screen to keep the critters out. And then it has a piece of paper towel, okay, also to help slow and keep a little micro colony, like a little greenhouse almost, that fosters, okay? And then you come back 5, 6, 7, 10 days later, depending on the temperature outside, and hopefully you pull off the top, the screen and the paper towel, and you see that, okay? That's a very nice collection, and that's IMO right there. Okay, that's would be considered IMO 1, but it's IMO, okay? I think I might have some more. All right, all right, amendments and ferments. Okay, so we have the IMO. Okay, that's the basis of it. We're going to make IMO 2, 3, 4, and 5, which basically just increases it. Actually, let me get that. Do I have another picture box? Maybe I didn't know. I didn't know. Okay, so I'll go back to this. once you have this material, this IMO collection, you bring it back to your farm. Preferably you want to take like 10 from different seasons and from different locations. So I go to the Cedar Swamp Trail, I go to the woods behind my farm, I go to the dunes, I go to a cranberry bog. I'm trying to get the diversity of microbes, right? So I get like maybe 10, right? So I have 10 boxes, not all every same day, of course. I then take that rice, okay, I scoop everything out of this whole container and then mix it 50-50 equal portions to brown sugar, okay? So now there's my second input I had to buy. I had to buy some rice, white rice, and I had to buy some brown sugar, okay? I tend to try to buy organic fair trade sugar because it's better for child labor law, you know, the people that are producing it. So that's where I go, but any brown sugar will work. White sugar doesn't quite work as well. What that does is that takes all those organisms, and that's not just fungal. We're talking bacteria, particularly if it's in a bamboo. We can make these for bacteria dominant too. This is fungal dominant. All those organisms, when we mix it with that brown sugar, it puts them in the organisms in a suspended state of animation. Okay, it holds them in place. It through osmotic potential, it pulls the moisture out of the microorganisms and makes them sporulate and stay there and hold their weight. Okay. As soon as we add moisture back to that or something else and some kind of carbon source to feed on, boom, the microorganisms grow. And that's IMO 3. So IMO 2 is this collection plus equal parts brown sugar. It's shelf stable. I can put it in my jar. I can stand up on my shelf out of the sun, yeah, with a breathable lid. So I use mason jars where I take the metal part of the top and I throw that away and I take the ring, I put paper towel down and I screw it down and it can breathe, okay? Biological systems need to respire. We don't want to go anaerobic. That's no good. We want to go aerobic, okay? So that's IMO 2. I can put that on the shelf for almost indefinitely, pretty much indefinitely. If I have to, I could super saturate it by adding more brown sugar, but I can leave it there for years and years and years and years and years, okay? And now when it's time to make IMO 3, I take a little scoopful on my finger and I add it to a 5-gallon bucket of water and I put some other ferments now, okay, some of these other inputs that I'm about to talk about, okay? I put them in there and then we get a special kind of compost pile that's got carbohydrates that's a carbohydrate source and a carbon source. So for me, I'd like to use rolled oats. It's kind of available. You go to a feed store. Some people use mill run. There's all different types of whatever's available in your area and it's cheapest, right? Chris Trump is fortunate. He's got macadamia shells here. So we also use that plus wood chips, okay? Just normal wood chips that we have plenty of. You go to Dunkin' get them, okay? And it's typically like a 75-25. You play with it, okay? Depending on what you got, barley or oats or whatever as your carbohydrate source. And the carbohydrate source now, like the rice was, is now the food source. And I mix everything in there with a little fulvic acid, and then I put it on this special mixture of carbohydrates, for me, rolled oats, okay, or pressed oats and wood chips, and I build like a trapezoid. And I mix it all well with water, and so a nice equal combination of this bucket of all these organisms and all this other good groovy stuff. And I put it in there. And those of you who have made good compost, you know how the things heat up, right? Well, I'm making IMO 3, the science of it, the art of it is that you want to let the temperature get up to about 120 and then stabilize there and then slowly drop back down. What's going to happen is it's going to start to go above 120, at which point we turn and mix that pile and we flatten it. We give it less bulk mass and we start to spread it out a little bit and slow it down. Then it goes back up to 120. So when making IMO 3 and IMO 4, the problem is, and why some people think it just takes too much work, is you really can't go anywhere for like a couple of days, like 72 hours pretty much. You have to kind of you kind of have to take care of it, okay? To the point where some people have put up fancy alarm systems to their compost thermometers. When the temperature gets there, they fling it over, okay? So once that happens and everything settles down, you'll go inside that mixture of rolled oats, in my case, barley in Boz's case, or whatever, other people, whatever we use. It starts to smell like bread, okay, like bread, like yeasted bread, okay, fresh bread, and that dough, okay, and it's clumpy. And all of a sudden, that same clumpy look in here is now like this size, this big pile of it, okay. So we took something that's this much rice, right? This is a big IMO box, by the way. take this much rice and you turn it into like that much, and you pull up and it's clumpy and almost looks like tempeh. There's the tempeh where that white mycelium goes in there, right? All that life is in the tempeh. It's the same thing, that all that stuff's to clump together. It starts to form with the carbohydrates and the sugars, everything starts to clump together. And that is IMO3. And then we take that and we put it in giant piles of compost and wood chips and other things, and we make IMO4, and we get it to the size of this room. Okay. Now with Chris Trump and people scaling up, tractors get involved, right? But you can do it at home. You can make IMO4. And then the IMO4, we spread all over the fields. We re-inoculate all of our fields with IMO. That's the foundation of it. Okay, you're going to do it in your gardens. I'm going to do it in my fields. The Vietnamese rice guy who's growing hundreds of acres of rice paddies, he's going to do it with his rice paddies. Okay, that's the fundamentals. Chris helped create a shortcut called liquid IMO, which is taking that one little scoop of IMO2 and brewing it in a compost tea, an aerobic tea, and multiplying them that way, giving them some air and some food in the tea. This is something that a lot of organic farmers use, compost tea, a lot. So incorporating the IMO2 into a compost tea and then getting it onto your crops via soil drenches. And then we use it as a pesticide, and not pesticide as much, but more of a fungicide to kill the bad funguses on our leaf surfaces, because we're putting the good funguses, all these good things on there, the liquid IMO. So now there's liquid IMO, LIMO, okay, liquid IMO, and there's also IMO5, which is really going down the rabbit hole. But I finally made my first batch. I use a very high nitrogen source. I compost the grape pressings from the vineyard. I have been for a long time now. All of their stuff gets recycled on my farm. It goes back into growing some of the Angelica that they use in their gin. So you can see the cycle going right with my local neighbors. Okay, so you can up this little box with my IMO5. I turned into half the size of this room or more of compost to add to my fields. Okay, so IMO, the basics. Okay, we're going to go into real quick now the ferments. Okay, KNF ferments, amendments and ferments. Amendments are the same thing as ferments in this situation. KNF uses a variety of amendments either to directly enhance plant growth, plant enzymes. Remember, that's what we were talking about. What he was studying, or to enhance ionomal proliferation. We want to increase it. KNF ferments a variety of materials for use in different contexts. Every input, every KNF ferment has specific reasons for it. Okay, and I can't get into it. You guys can go down Chris Trump's rabbit hole. It's all on the internet. ChrisTrump.com is his site. Go to his YouTube channel, Chris Trump. Just Google YouTube. Go to the foundation. Go to the principles. There's the first one you got to do is the principles of KNF, and then you can go into all these ferments. How to make FPJ, how to make FFA, how to make all these great things. Okay. IMO, we talked about that already. Okay, that's the most important of all. Okay. FPJ, fermented plant juice. I take weeds, chickweed, weeds that just grow amazing with no human intervention. Ragweed, this, that. I don't care what the weed is. I take it during different parts of the seasons, right? Early spring young growth. Okay, I take that, whatever that volume is. Let's say it weighs a pound. Then guess what I have to mix it with? A pound of brown sugar. It's back again. Okay, the same brown sugar I bought. I'm now using that to make my ferments. That sits for usually about 4 or 5 days, whatever. It starts to do its thing. We then strain it, and we have FPJ. It has to be a breathable lid. All ferments do. Then we have FPJ that we can spray on our plants and then utilizing other inputs down the line. Okay, so that's the basic. Weeds have now become, in essence, my fertilizer. Okay, does that make sense to everyone? It's not technically the NPK kind of fertilizer you see on a fertilizer bag, but it's to all those microorganisms. All that microorganisms on the air get into the ferments, on the ones that are initially all the organisms on the weeds themselves. And the reason we're going for that young spring growth, that early growth, is because in the spring, we want our crops to spring, jump forward with vigor, okay? Find natural plants. Chickweed's a really good one, guys, up very early. We can make FPJ out of that, it's great. I use Rosa rugosa. Find a plant that just kicks ass in nature, and then get it in, mix it equal parts brown sugar, let it ferment a few days, strain it, go to the website. And there's a lot of literature on KNF, guys. to figure out how to make these things. But I can tell you for the best way to go is either Drake or Chris Trump's. They both have YouTube channels. They know what they're doing. They learned it from Master Cho. The rest of us are all their students. Okay, now there's ones people doing it longer than me, and they're also my teachers, but really important. So the enzymes that makes that chickweed grow so vigorously and so strong and so virulent in the earth, those enzymes are what you're spraying on your plant, or you're drenching in the soil. That's what gives the plant the fertilizer effect. Okay, the like so-called fertilizer effect. So I'm creating my own fertilizer. Okay, so I'm no longer buying stuff. I don't go and order, you know, organic fertilizer, whatever, chickadee doo or any of the, whatever it is out there. There's plenty of them on the market. You can go to all your nurseries and buy organic fertilizer. I don't have to do that anymore. I don't do that anymore. What I'm fostering now is the food web and letting them go get the nutrients that we have in this coarse sand for me. Okay, so when that happens and that by vibrating enzyme life of those energies, that energy bursts into and thrives into the plant you're growing. Okay, making it strong, healthy, bioddense, nutrient dense. Okay, OHN, Oriental Herbal Nutrient. I should have started that one because that's one of the first ones to be. It's the longest one to make. Takes many months to make it, and that it's used in almost every other ferment. Okay, so it's really important that I should have had this one first. IMO for sure first, but this should have been first. Okay, it creates an immune system boosting inside. It's a tincture, like an alcohol tincture that people make. Sarah Nasiri, I'm sure makes lots of them, and that helps your plants get strong, you know, on the inside out. Okay, so what we do here is we take cinnamon, garlic, ginger, angelica, those four. We put them in big jars. We pack it pretty tight. Not always 2/3 left open for that airspace, so we're getting anaerobic. So we keep it aerobic, breathable lids, and we put it with high strength vodka or Everclear or something like that. Okay, and it sits there, and then we stir. Master Cho says we have to stir clockwise. Okay, so we follow his protocol. If you do KNF, you follow the rules. Okay, every day, a couple times a day, I think. So once again, you can see it's got to kind of hang out with your big jars, right? Okay, so you're doing that for a while, and then towards the end of the process, you add beer to it. You saturate it with beer, so you have this much volume, and then all of a sudden you're adding equal volumes of beer. Beer stops the fermentation process, the extraction process, and then kicks in some ferment process, and does some conversion of sugars and things, and stabilizes that stuff at the end of it. Okay, so then we strain it. All the stuff we strain, just like our FPJ, goes into the compost. We now have jars full of angelica, OHN, garlic, ginger, cinnamon. Okay, so when we make our OHN, we take equal portions of those, and we add them into a thing, and that's OHN. That's Oriental Herbal Nutrient. When you have a cold, you're feeling sick, you got something starting to start up, you take a couple ounces a day every day, boom, you get better. Okay, it's really phenomenal. Everyone knows about the properties of garlic and ginger and all these things. Okay, that's in essence what this is. Okay, old tradition stuff used in Master Cho's vision for a paradigm shift in agriculture. Okay, lactic acid bacteria. The way it's a germicide, promotes growth of fruit trees, leafy greens. It does so much gut health. It helps livestock. You can put it in the water. I put it in the water with my chickens. They drink it. I drink it. If I'm feeling a little upset stomach, maybe I had a lot of fatty foods for dinner and my stomach's just not, I'm just like, oh, that's too much. Take a shot of lab. Boom. You feel better almost within an hour. Okay. So the way we get this is we take the rice that we're making our IMO with, right? And we rinse it. If anyone's ever strained and rinsed rice, you notice the cloudy water that comes out of there, right? That's the rice wash. Okay, that's what we call rice wash. So we rinse the rice that we're using for our IMO, the input we bought, and we're taking out the starch in that rice wash. Okay, so that rice wash now sits on the counter in a breathable lid for a few days, depending on temperature, all these kind of things, humidity levels, and it starts to get like kind of sweet smelling at first, and then it gets like kind of really sweet smelling, and it kind of goes through everything. All these ferments and everything has to be smelled and tasted to really learn how it works. And that's the benefit of taking a class with Chris Strong, is you're going to smell it and taste it. And that's really how you know you did it right. Okay. We make tons of mistakes when we start Korean natural farming, and that's the best teacher we have. When you make a mistake in life, you don't have to write that down later. You remember what it was. Okay, we all learn from our mistakes. Well, hopefully we do. I tend to take a while, but so we have this rice wash. We let it get the bacteria that's in the air, the bacillus mainly, the lactic acid bacteria in the air that we're breathing right now gets into this rice wash. It starts to go from like kind of benign smelling like nothing, and the smelling a little sweet and a little more sweet, and then it just starts to get to that kind of like sour smell, and that's when we add it to milk. Okay, what do you think happens to the milk? Just like making cheese, right? You separate the milk, the curds flow to the top, and the whey goes to the bottom, right? And that's what happens. We do this on our counter, breathable lid, of course. It separates. Then when it separates, so now we're using white sugar, brown sugar, white rice, and milk. Those are the only things I've bought so far, aside from some jars, and hopefully you can find those. Now, that separation, you take the curds, you make cheese out of it, feed it to your animals, feed it to your compost, whatever, it goes away. That whey is what we call lab, okay? That's what I take a shot of. Put it in your fridge, it can last forever. You can super saturate it with brown sugar and let it sit on the shelf, and you'll be fine, okay, for a long time, all right? So lab, very cool, very important. Fights powdery mildew, we spread, helps build up pathogen resistance on the plant, just like it does in your body. FPJ, fermented plant juice. Did I already do for FPJ?
Yeah.
I did, look at that. That meant to be FFA, fermented fruit juice. More use it towards the end of the cycles when you're trying to get your fruit to develop. Get the enzymes from that, okay? It doesn't mean going to the store and buying a banana or an avocado. It's fruit near you, okay? That's the wrong fruit. You need naturally growing fruit, nothing that's been shipped, raw or, not ripe. Okay, you can read that. FAA, a little freaky. We take my son's mackerel. I say, Reese, I need some fish. He goes out and gets me a bunch of mackerel. Boz and I chop it all up into pieces, put it in a cooler, an old cooler that's not with a tight lid. Once again, we weigh it. If it's 5 pounds of fish, it's 5 pounds of brown sugar, folks. Same thing. And guess how long this one sits for? A year in that bucket. You can imagine what happens. But the problem is you think it's going to get nasty, right? But because of all this biological activity and the fact that there's a little bit of air getting in there, nature does its work. It ferments it. It does its own work, okay? Has anyone ever had fish sauce, Thai fish sauce? Probably a few of you have. Guess how they make Thai fish sauce? They chop up fish, they put brown sugar in it, and they make fish sauce. FAA is fish sauce. Same thing, okay? It's amazing. It has some nitrogen effect, has a fertilizer effect, but it also has this enzymes and these other good things, okay? Okay, nitrogen a little bit. All right, so I'm no longer buying fish emulsion on my farm. If I was going to use fish emulsion, I may use FAA. I don't need it too much anymore. I did it in the beginning. WCA, I got a fly now, guys. Water soluble calcium. It comes from eggshells and vinegar. Whenever we use vinegar in a Korean natural farming system, it has to be a live vinegar. Brown rice vinegar is typically we use. Something that has what's called a mother. Okay, in the bottom of the thing, we want to use live vinegar if possible. That extracts calcium. We do that, we add that. And all these ferments, when you see, if you go down the rabbit hole, we're using 1 to 1,000, okay, per gallon. Okay, so or per whatever. 1 part WCA to or this one's a little bit different. So let's use FPJ or lab, 1 to 1,000. I'm putting drops in a gallon of water. I'm putting 4 mils in a gallon of water, guys. I'm not buying a big bag of fertilizer or anything else. I'm putting drops. A little bit of this stuff goes a very long way, keeping your costs down and effectiveness. Okay. All right. I'm going to move along. Here's your calcium phosphate. You're looking for phosphate in your plants, of course, right? All right. SCS, a seed soaking solution or a maintenance solution. This will really charge your seeds. I soak my seeds in it before I plant. I get all these good, there's a lot of things in here. There's OHN, there's FPJ, there's IMO2. There's a lot of things in this one, okay? Those are things, SES is, I use a lot, okay? It's maintenance solution. It's a really regular spray for me. And it really just pulls out the potential of the plant, okay? Soil treatment solution, very similar to rehabilitate and just give your soil a little vigor. After you've put your IMO out, let's give it a little charge, okay? And if you have a new garden, really important to get into SOS first, okay? When you break new ground. Okay, the nutritive cycle. This is from Chris. This is from the class. This is where and when these different ferments and things happen in the nutritive cycle of a plant. A lot of people, particularly Drake, will explain it as in like a pregnant woman, the process she goes through of birth and the child growth and the teenage years and the development and the old aging and the fruiting and all this stuff. Very interesting, not too complex. It does seem a little crazy, but so if you see things like baby making, baby cumulative growth, that's kind of that baby thing that they come up with, okay? Please go to Chris Trump's natural farming stuff, information, and Drake's, and you'll learn all about this stuff. I can also answer questions. In nutritive cycle, there's type 2 we use for the vegetative growth, okay? Gets plants going and off to a good start. 2, when we start to reproduce in the fruiting process, okay, we're gonna go for that. Korean natural farming is an elegant method to tend to the life of your soil. Master Cho created something beautiful with the intention of a paradigm shift in love and a way of reducing costs for farmers so that we can stay in business and then heal the planet through the soil, okay? Increase the health and production, whether you are a backyard gardener or a commercial farmer through KNF. I had to add that part in there. It can be scaled down to the smallest of gardens, okay? And if you're in a container garden, you can't really have a soil food web, a living soil, in my opinion, unless you have a 50-gallon pot, okay? Not a 5-gallon bucket, not a little container this big with your tomato plant growing in. 50-gallon pot, okay? Minimum. 100 gallons on my farm. If I'm gonna grow a plant in a pot, it's 100 gallons. I usually use a 400-gallon pot, okay? That's a 400-gallon pot is, for me, a little past the camera, so it's probably 5 feet around, in diameter, and about yay deep. And I'm gonna charcoal mixing for me, so he's a good sail maker. Find a sail maker if you want to go one. Okay, biodynamic farming, guys. I'm sorry, I had a feeling I was gonna have to skim through this. This is a very well documented way of growing food. I've been doing it for years. It's created by Rudolf Steiner. There's a definition. Biodynamic agriculture is a form of alternative agriculture similar to organic farming, but it includes various pseudoscientific, because back in the day, it was all like feely touchy stuff, right? And esoteric concepts of Rudolf Steiner, initially developed in 1924. It was the first of the organic agricultural movements, except for maybe Sir Albert Howard, who went ahead of him. He's the father of organic agriculture. He did a lot of work with cover cropping and manures and rehabilitated soils in India that way. So not quite the beginning of organic agriculture movement, but a defined system, okay? Using the moon plantings, the sun, the spiritual, a lot of clockwise stirring, but then counterclockwise stirring to create chaos in the universe, okay? So you're seeing where this is going. Rudolf Steiner created the Waldorf school system of education. Many people know that. A form of practical medicine, anthro something or other, I can't think of the name, but agriculture, education, medicine, and beekeeping. Like I said, it's part of agriculture. This man was brilliant, okay? Go down the rabbit hole, okay? Holistic ecological approach, compliant anywhere, it's amazing. They have its own set of nutrients inputs, okay? They're called preparations. I'm a fan of preparation 508. It's manure stuffed inside the horn of a cattle. Okay, that's bored out, you know, after it dries, the marrow dies and all that stuff and everything goes, and you pack some compost in there with some nettles and some other plant extracts, right? You take those horns, you bury them in the earth for a year, you dig them back up, you scoop out everything that was inside that horn, you add it to your bucket, you counterclockwise, and then create some chaos and counterclockwise, and you have preparation 508. Okay, 505, 502. There's a lot of preparations, a lot of botanicals used here, nettles, yarrow, echinacea, all these things that you're already listening and commenting about already. This guy was doing it to make inputs for your farm and to just magnify with magic. That's the only way I can explain it. Magic is what this guy tapped into, okay? So manures, composters are the thing. A lot of this stuff is the same stuff we talked about. It's a living organism. Soil is a living organism, guys, okay? Cultivates biodiversity, generates on-farm fertility, sprays enhance the soil and plant health. Okay, there we go. Thank you. We're here again. Galen, you rock. You guys have been the best here. If anyone ever has the opportunity to teach a class here, I wholeheartedly say you jump into it. All of my teachers, Chris Trump, Master Cho, Elliot Coleman, Dan Kittredge's family, everybody, Wendy Kornberg, Kobe, I have so many. All of my Buddhist teachers, all of my other my friends who teach me, Donald Trump, who I despise, but he's a good teacher for me, everything, all my teachers, all of you, okay? The microorganisms are my teachers, my dog in my car is my teacher, everybody, okay? I want to thank all of my teachers. I want to thank you guys for attending and sticking through the thing. And I'd like to dedicate my educational efforts to all sentient beings. May they use this information to create a better community and planet. Let's make the paradigm shift happen that Master Cho envisioned. Let's do it. All right, there we go. I don't know if do we even have hours of questions? All right, I knew I couldn't do it. Like I said, I apologize. This is literally like an 8-hour course I could have just given right here on just KNF or regenerative farming alone. And you guys are my test guinea pigs. I apologize. Please go down the rabbit hole, Google all those 3 terms: regenerative agriculture, Korean natural farming, Master Cho, Chris Trump, and then biodynamic farming is Rudolf Steiner. The Demeter Institute, there's a biodynamic.org. There's a lot of information on biodynamic stuff. There's a lot of information about Korean natural farming. Remember, stick with the main teachers, follow Master Cho's recipes. If you want to experiment, his son created something called Jadam. Okay, he experimented. He thought his dad's system was too expensive with the brown rice and the sugar and all that, the brown sugar and the white rice, and he thought that was too expensive for farmers. So he created a model that's really applicable in third world countries where they don't have access to that stuff. So experiment, do side-by-side trials. Okay, don't just start going willy-nilly. Make sure it doesn't go anaerobic. People can get sick. You got to really kind of follow Master Cho's and Chris Trump's recipes to the letter, and you'll be fine and safe, and you can ingest everything that you can spray on your plants. Okay.
Thank you.
Questions? What do we got?
I didn't get anything on here. Some
All
people
right, any
dropped.
questions from here?
I didn't think I could see any questions today.
If
All right,
anybody,
I'm sorry your heads are all spinning. I appreciate everything. Thank
If
you so much,
anybody-
everybody. Thank you.